Hey guys, in this lecture we are going to prove multiplication property of DFT. And the statement of multiplication property of DFT says that statement if DFT of x1 of n is equal to x1 of k and DFT of x2 of n is equal to x2 of k, then DFT of in time domain, if I multiply two signal x1 of n and x2 of n, so in frequency domain it will be convolution, circular convolution, x1 of k n point circularly convolved with x2 of k, but with a scaling factor of 1 by capital N, where capital N is the number of point. So we'll try to prove it. So proof. So what is from the definition of DFT? So what is DFT of x of n? DFT of x of n is summation k varying from 0 to n minus 1. This is n actually, summation n varying from 0 to n minus 1 x of n e power minus j 2 pi by n into kn, right? So if this is the case, what is DFT of x1 of n into x2 of n, right? This is what I wanted. No, is equal to what? Summation n varying from 0 to n minus 1. So this x of n comes here, and the signal exactly comes here as well. Okay, so x1 of n into x2 of n into e power minus j 2 pi by n into kn. So what do we do is, let x2 of n, I'll be defining x2 of n. What is this x2 of n in terms of IDFT equation? It is 1 by n into summation. So I'm not going to take k, but I'll take some other variable. In this case I'll take it as L, because k it's already been used, because later on I have to substitute this equation in this equation. Okay, in this equation 1. So L varying from 0 to n minus 1 x2 of L e power plus j 2 pi by n into, so instead of k I'm putting L into n. Let me call it as equation number 2. So substituting equation 2 in equation 1, so what do we have as a right hand side? Summation n varying from 0 to n minus 1 x1 of n, and instead of writing x2 of n I'll write this equation, which is 1 by n into summation L varying from 0 to n minus 1 x2 of L e power j 2 pi by n into L into n, into left out term is e power minus j 2 pi by n into k into n. So rearranging order of summation, comma. So what I'll do is, so I'll write 1 by n first, and I'll take summation L varying from 0 to n minus 1. So this 2 I'll write it here, x2 of L, into left out term is summation n varying from 0 to n minus 1 x1 of n, and I have two exponential, and I can take few terms common. So I'll take e power minus j 2 pi by n into, so n is common, so I'll take this term common. So what is the left out term? So it is e power minus j 2 pi by n into k, and minus into minus plus, it is L. Now so what is x of k? X of k is what? Summation n varying from 0 to n minus 1 x of n e power minus j 2 pi by n into k into n, right? So instead of k, if I write k minus L here, what happens to the left hand side? Left hand side also, so it's end up with k minus L, right? So what happens to this equation now? So this will be x of k minus L, right? And what is the left out term? This is equal to 1 by n into summation L varying from 0 to n minus 1 x2 of L. And this I can interchange because this is a convolution equation, and convolution holds good commutative property, so I can write it as L varying from 0 to n minus 1 x, this is x1, right? This is x1 of k minus L, so this is x1 of k minus L into x2 of L. And this equation in short I can write it as x1 of k n point circularly convolved with x2 of k. Left hand side is what? DFT of x1 of n into x2 of n. So multiplication in time domain is equal to circular convolution in frequency domain.